Exercise 30, let's prove that in any category, equalizer, if it exists, is always monomorphism. Okay, so this is very easy, just follows from the definition. In particular, this will tell you that this corollary of the kernel's monomorphism, and in the opposite category tells you, using the opposite category tells you that. So co-equalizers are epimorphism, and in particular co-kernel is epimorphism. So let's prove. So suppose we got two objects A and B, and let's define the E to be the equalizer of morphism F and G, call this small e. And so by definition, this means that firstly, F compose E equals G compose E, and secondly, satisfy the universal property, which means that for any object with a morphism H such that F compose H equals G compose H will imply that there exists unimorphism, let's call it alpha, such that this diagram commutes. Okay, and so we now check this equalizer E is monic. So what we do is, instead of put say here, let's put some more precise ones. So the first we put here, let's say we want to check its monomorphism for any D and for any two morphism into E, F1, F2. Suppose the composition is the same, so we call this composition, so this map here, okay, give it a name. So let's call it just F, E compose F. This is E composed with F1 and also E composed with F2. And so now the question is, if E compose F1 equals E compose F2, does this imply F1 equal F2? If this is, then this is the definition of E being monomorphism, but this is because, so by the universal property of equalizer, you got your map, let's call this gamma. So your gamma, basically it's just E compose F1 or E compose F2, okay? You got your gamma compose, F compose gamma equals J compose gamma. And so by the universal property, it implies that there exists a unique map from D to E, makes the diagram commutes. And so this is telling that F1 must equal F2, because both F1 and F2 make the diagram commutes. Okay, as a corollary, this tell you that the kernel of any map in any category, if it exists, is monomorphic.